remember one of the things you were like wondering is, how do you know when to do this? How do you know if you got to write it like this? I mean, how do you know? And I said, you're gonna know when I start this. So look at the handout. Guidelines for proven identities. This is not like geometry, I already told you, where it's a 2-column proof. That's not what this is. Now, this is going to be a very, very basic identity. You have to prove that. This one ain't going to be real hard. I'm going to just introduce it here. Now look what it says on your paper, because you've heard some of this. Number 1, learn the fundamental identities. Gentlemen, by now you should almost have them memorized. Those identities, got to know. You're going to be using them all the time. Whenever you see either side of a fundamental identity, the other side should come to mind. Always look for opportunities to use the identities or any of their alternative forms. I've been telling you that. Look what number 2 says. Try to rewrite the more complicated side of the equation so that it is identical to the simpler side. This is working with one side. This is how you're going to do them. Now, when we get back after Christmas, these are going to get much more involved. But you need to understand how to do the basic ones first. So, your first order of business is, here's an example. The first thing you got to do is pick a side. And that's the side you're going to work on. Now, the more complicated side is obviously the left side. There's more stuff there. So that's what I mean by pick the more complicated side. So that stuff that's over there on the right, you ain't touching it. Remember I said you're going to know what you want to get? You want to start working with this left side until you get it to look like that. And once you do, you proved it. That's what I mean when I say proven identity. Now look at the study sheet. Look at number 3. It is normally helpful to perform any factoring or any indicated operations. The sum or difference of 2 trig expressions can be added or subtracted in the same way as fractions. Now, what have I been telling you since last week? All the algebra that you learned, you're still, what's the matter, John?
For like this, will we ever prove that it's not the right answer?
No, never. No, any problem I give you is legitimate. It'll always work, if that's what you're asking. No, any problem I give you will be legitimate. It works. So number 3 is saying algebra. Use all the algebra, adding fractions, LCD, factoring. That's why we did those things yesterday with factoring, trig stuff. All that stuff you've been doing, it's all going to come into play here. Look at number 4 says, as you select substitutions, keep in mind the side you are not changing because it represents your goal. Now, the only way you're going to get better at this is with practice. Now, when I finish this today and I give you the homework, you're doing this by yourself. You're not doing it with the kid next to you or anything. That's what was going on yesterday. No, you're doing this yourself. It's the only way you're going to learn how to do this. Now, you see number 5? Don't worry about that yet. I'm not ready to talk about that. Look what number 6 says. It is sometimes helpful to express all trig functions in terms of sine and cosine and then simplify the result. Isn't that what you've been doing? Now, this is going to sound weird, but it's so true. Look at the note. This could be like the only time in math I can say this to you. When you're trying to prove identities and have absolutely no idea what to do, and this is so true, and you're going to find that out, look what I'm saying to do. It's probably the only kind of math problem I can stand up here as a teacher and say, look, if you have no clue how to do the problem, I'm telling you what to do. And look what it says. It is suggested that you change everything to sines and cosines and simplify the result. And it will work. Now, is there a better way to do some of these? The answer is yes. Now, I'm not going to lie to you. Today and tomorrow will be pretty basic. Today and tomorrow will be pretty basic. Now, when you do these, when you prove these identities, is every person in this class going to have exactly the same work shown? The answer is probably not. But, you know, these 2 guys here could do the same problem. And what they're showing me is not exactly the same, but they both could be right. This is a hard test to grade. I'm not making excuses, but it takes time on this test. I got to look at every little thing you're putting down. Now, could somebody do one of these in 3 steps, and somebody else could do one of these and it took them 10 steps? The answer is yes. So, in an honors class, you want to try to do it the best way. You will learn this after time. Now let me just show you this. I have 5 examples to show you, and then there's 9 you're going to try to do in your book. And this is where we'll start today. So if I said to you, prove this identity, with everything that I did all last week and yesterday, you're obviously going to pick the left side. You all clear? You pick the more complicated side. Okay, now I'm not going to say anything. What do you think you're going to start to do on the left-hand side? This is stuff I've already taught you. And now, I'm going to keep bringing this up. And there's one more thing I probably... Look at the bottom of that study sheet. There are usually many ways to prove or verify a given identity, but with practice, that's what I just said, you will learn the most effective approach. And you see the special note at the bottom? Fellas, never do that. When you take this test eventually, sometime after Christmas break, never do what it says there. Never leave a problem blank on proving an identity. And you might be sitting there going, well, what if I don't know how to do it? I'm telling you what to do when you don't know what to do. I know that sounds weird, but I'm telling you what to do when you don't know how to do. So, what are you going to do on the left-hand side? See, I'm already, right out of the gate, every hand should be up. And I know some of you are going, oh my God, this is the first example. What's he talking about? No, because I just said something to you. You guys that are just sitting there means you don't know what to do. So, I'm telling you what to do. That's why I'm saying never leave a problem blank, even if you don't get it right. You know when you take a test for me, if you leave a problem blank, it's minus full credit. If you put stuff down and some of it makes sense, that's partial credit. Never leave a problem blank. Jim.
You change cotan to cosine over sine.
Cosine of x over sine of x is cotan. Now, guys, you need to get this in your notebook. Over
Cosecant equals 1 over sine.
Cosecant is 1 over sine. Now look, I'm not going to lie to you. I'm going to show you a few today. They're going to be kind of basic. This is just giving you the idea. Now, here's another thing where some of you might get in trouble. And, well, I know it'll happen. Because when I grade this test, I always put on here, not enough work. Not enough work. You didn't show me enough. You got to make sure what you're doing is legitimate. And you can't say, well, you know what I meant. No, I don't know what you mean. You got to show me. Continue. But keep in mind, gentlemen, that's your goal. Once you get this to look like that, the problem's over. You proved it. This one ain't a hard one. Alex.
Yes, sides
Fraction divided by a fraction means take the fraction on the top and multiply by the reciprocal, right? Reciprocal of 1 over sine is sine. This is what I mean about showing the work. And then those cancel out. And that's cosine. And there's your check mark. Now that was a kind of basic one. Now, what I did there, isn't that the stuff you've been doing now? And all them other problems, converting the sines and cosines? Now do you see what I mean when I said you're going to know how you want to get it? Because you're going to see what's on the other side. And that's your goal. Chris?
At the first part, I multiplied the left side by the reciprocal on the right side.
No. Good question. You can't do anything to the other side. You're only working on one side. You understand? You can't touch the other side. You pick the more complicated side and just keep doing the work. Once it matches that, it's done. You proved it. So no, you can't do that. You can only work on one side. Okay, write this down. Example 2.